All right, in this video, we're going to assemble the Tamiya 72001 planetary gearbox kit. And I'm just going to go through it in real time, give a little bit of running commentary, and that you probably want to watch this at like a 2x speed so that it doesn't get too boring for you. All right, so I'm going to start with the box. Very, very beginning here. Open it up. And what we'll find inside are a few packets of injection molded components and some instructions. And the instructions are actually quite good. It's best to read through them carefully before you get started. There's Japanese and English, so it can be a little confusing, but everything you need to know is in here, really, except for a few little tips that we'll provide along the way. So the first thing to do is to open these plastic containers, and we'll snap out components from the injection molding screws there. You can just pop all of these out. Bing, bing. There are some extra parts in here that you won't need. This is for a different motor than the one we'll use. And these are some ways of connecting to the output shaft of the gearbox that we probably won't use, at least not for this project. So we can set that aside. So these are going to be the exterior parts of the gearbox, and they'll form the interior gear for our planetary modules. Next bit, not to mash things inside too much. Whew. And then pour those out. And we can see we've got a bunch of little free gears. These are going to be the planet gears in each module. And then we have, still connected to the screw, we have these sun gears. We'll pop those off. And then these are the cages that will hold the planets in place and the sun for the next stage, connecting the sun for the next stage, and make everything go. All right. So now we've got everything snapped out of the plastic that it was molded in. We can start to clip off all the little tabs. We can kind of move these off to one side, and then find each little tab. Oh, there's one right here, and clip it off. And we want to make sure we really get those tabs off fully, because if there's a little bit of material left from that connection to the sprue, it will prevent these parts from fully clicking together. And we need them to do that. Otherwise, the dimensions will be wrong and things will grind on each other inside the gearbox. Okay, that's 1/2 of one cage. There we go. Here's another one. So when I'm doing this, I err on the side of cutting off a little bit too much material. All the regions where the screws attach are not essential for the strength or for the gearing functionality of the gearbox. So, and these are the clippers from your 3D printer kit. These are fantastic for this purpose. All right, so almost done with the second cage from for the 5-to-1. These are going to be the 5-to-1 stages. All right, and now we'll move to the cage for one of the 4-to-1 stages. So we'll see this a little bit later in this process too, but the color coding here is that the color of the meshing gears should match. So, and then the color of the cage should match the planets that it houses, but not necessarily the sun that press fits into it. And that'll become clearer in a moment. What I mean by that. All right, clipping this little. All right, and then we have the sun gears. And here, you want to be careful not to mar the surface of the teeth or this, this sort of dog clutch shape that's going to use to press fit into the cage. But you can be pretty aggressive though on clipping a little of that material off the side. You really don't want these things to not seat properly, not seat fully into the cage. Otherwise, yeah, grindville. All right. There should be a little tab. Oh, there it is. There we go. All right, and then we have, so these came already without any tabs. They really need to be precise for this thing to work well. And then we have, let's see, these little connectors here, and we're going to be pretty aggressive on those. They're not super important to the strength of this system, but if they're in the way, it really might not fit together right. So once you get when you first start, you might go a little slow on this stuff, but once you get used to it, you can move with some speed. Let's see. All right. Yeah, these ones don't want to interfere with that little snap mechanism. That can be quite a nuisance. All right. And finally, this is the part that will connect to the motor, and this will snap the motor in place. And this is the part that will house the output shaft. So it has this little extra flange sticking out there. And if you do a free body diagram of that output shaft, you'll understand why. Helps reduce the friction. Alrighty. Now what we can do is put together the gear stages. So we'll start with a 5-to-1. And this might be a good time to bust out some grease. Inside your kit, you're going to find this little blue bottle of grease. And I like to try to put a little bit of grease on every surface that has sliding. So the inside of these shafts, the gears, and you can see my older son just got back from school. That's nice. But these shafts will hold the planet gears, and they'll rotate on there. So we want those to be able to rotate smoothly. We'll add a little grease. And then on top of this, we'll place the other part of the housing. And now we're going to press it in pretty firm. I want to make sure it really is seated fully so that things don't grind. They fit together axially as intended. All right. Now, the sun gears are going to go in here, but which one you put in there will depend on the stage order you want. So I'm just going to pick something at random. Let's say we want to go 5, 4, 5, 4, something like that. So we can put the whole thing together. Now, the way that this works is there's this little kind of dog clutch here and the mating surface there, and those things will press right into each other. You can see there's a little gap still, so you want to press it firmly until it seats all the way. All right. And now this sun will mate with these, will mesh with these planet gears inside one of these cages. So let's put that together. Once again, we'll put a little bit of grease. Shoot. And there's just a little bit of grease in here, so you want to use it sparingly, unless you go out and get a bunch more to use. And we recommend this brand called Super Lube. It's a silicone-based grease, and it won't damage the plastic that your parts are made out of. All right. Once again, we'll try to get this lined up. Oh yeah, that's right. For this one, I gotta check the alignment. This is not radially symmetric, and so there's a little notch in the top here and a notch. There you go. You can see the notch on the top there. Those notches need to line up for these cages to go together properly. So those lined up together, and then give it a good hard shove. We said we're going to go 5, 4, 5, 4. So the next sun should be a 5 sun. And so what will happen is these will mesh like that. And you can see that the sun gear here is contacting the inside of those planet gears, such that when the cage rotates, the planets are rotating, right? And the way it works is we have a stage here. We set this cage in and get it lined up. Then if we put, I guess we can do it this way too. If we set the 5 in behind it, so that the sun gear is meshing with those planets. As the sun rotates, see, the cage is rotating much slower. And the speed ratio is the inverse of the ideal torque ratio. So if we count carefully, we'll see that I have to rotate the brown cage 4 times for every 1 time that the orange cage goes around. It's 5 times. And so the torque is 5 times higher coming out of the cage. Ideally, of course, there's some loss due to friction. And that's something we'll be wanting to characterize in our tests. Okay, let's put together the remaining cages here. So once again, a little bit of lubricant. Those shafts proper gear. This time I'm going to note the notch location and then start this out with the right orientation. And there we go. Make sure it's nicely in there. And we said 4 would be the last stage, so it won't have a sun because it's not going to mesh with any new gear. Instead, it'll connect to the output shaft. So a little bit of grease there. Put on those planet gears. There you go. All right.
and go. And now, this is why we ask you to watch it at 2x speed. So there will be this 4-to-1 sun that's going to mesh with this cage, and we'll use this on the output of a motor. In this little brown plastic bag, you're going to find the electric motor, the Mabuchi motor that comes with your kit. Something to be super careful about is that these motor leads are really delicate. You can see this one's already kind of bent. There's only so many times that that wire can be bent back and forth, or the lead could be bent back and forth before they fatigue out and fail. It's like short cycle fatigue. And so you're going to want to protect those. And the way we do that is we'll take a hot glue gun and we'll just put a little bit of hot glue on the lead, and I'm going to use that as strain relief. So this is going to provide an additional mechanical connection between the wire and the frame of the motor. And you can be a little bit generous with the glue there, because we can always trim off any excess using our clippers. So we're going to put a little glue on. Oop. Oh, and now it's, I love when hot glue does that. Spurting out like crazy at the end after restoring it up a little bit. All right, so let's get that off. But you can see that we've got some pretty good lumps of hot glue there that will protect the motor. Let me just let that cool off for 1 second. And you've got now these chunky, pretty hard hot glue connections. We can snip off all of that. I don't think that's going to interfere too bad, but let's check to make sure that this thing can fit in there. So, oh, it's getting a little bit in the way, so we can clip it just a little bit of that material off so that this thing will slide in there as desired. And yeah, there you go. Now, no problem. All right. And while we're at it, we may as well take this and connect it to this component. So you can see these little positive snaps, and here's the negative part of the snap. We'll put the motor in, and you gotta push pretty hard to get this thing to go. So put that on inside and on the other side. Okay, and that's what's going to hold the motor firmly in place, connected to the rest of the frame of the gearbox. All right, and we're going to have our first stage after the motor be a 5-to-1. We've just chosen that arbitrarily for this case. You'll want to make your own decisions as you decide on your design. And so that means we need the orange sun to be on the output shaft of the motor. This is it requires some pushing. And if you just push on the outside of the motor, you can imagine what's happening is this output shaft is pushing on the rotor, which is pushing on something on the inside of the motor, which is then pushing on the frame. And if that something is bearings or coil, then it might not make your motor very happy. So I'll just take this, this is a scraper from my 3D printer, and line up the shaft underneath, and then push down here so that I'm kind of pushing, see that little nub of the motor shaft in the back. The thing that's being pushed on directly is that nub, and therefore that force doesn't have to be transmitted through bearings or the rotor and so on. And you can see that shaft surface now quite flush with the sun gear, the orange sun gear. All right.
now we can start to put things together. So if we take this this little bit of the gearbox frame and we put in our cage populated with the planet gears, this will fit on like so. And then when the motor rotates, it's going to make this cage rotate just as before, which will make that brown sun gear rotate. That will be in the next stage, and so on as a cascade through them. Now, before we put this together properly, we're going to want to add a little grease because we know that the efficiency of a gearbox is strongly affected by the coefficient of friction at the gear teeth. And so if I put a little grease on there, it'll circulate through and put grease on all of the planet gears and the internal gears in the gearbox frame. One other thing to note before we put it together is there's this little feature here, this rib on the outside of the gearbox. And you want to make sure that the ribs line up, and that will get you proper alignment with your gearbox. Okay, so we got the ribs, and then jiggle this a little bit to get the gears to mesh happily. All right, and it should not be hard to push in. So usually if there's difficulty, it's because of alignment. So if I spin this, it's going to make the motor spin now. All right, and let's add our next stage. That's going to be this, this brown one. Again, a little bit of grease on the sun gear, and find the rib, line it up, and then get things aligned. Right. It's going to get harder to rotate as you add more stages because you know the velocity of the motor is going to be the velocity of this sun gear times the gear ratio, the total gear ratio. And remember, the gear ratio is the gear ratio of this stage times the gear ratio of that stage. So first it was 5 to 1. Now it's 4 times 5 is 20 to 1. And that means that the speed, the position or speed are 25 times larger, then the acceleration will also be 25 times larger as you get up to speed. And so that requires more force. All right. There's also the effects of reflected inertia, so that it feels like what you're accelerating is 20 squared, so 400 times bigger. But that's motor and gear dynamics. We're not really going to deal with that in this class, but fun topic for more advanced students or students who go depth in this area. All right. Finally, we'll add the output stage. Now this stage, we're not going to include a sun gear because that is going to interface with the output shaft of the gearbox. More or less together. Let's see. Things back together. Come on. There we go. All right. Yeah, something doesn't feel quite right there. Oh, yeah. Well, probably gonna have to do this again anyways, but. All right. So let's see. This last stage, once we put it in place, is going to interface, there we go, with the output shaft. So this will eventually go on there. And you see these notches here. those will connect to the positive tabs in this output shaft. So it'll look something like this inside the gearbox, so that when the motor shaft, the gearbox shaft rotates with the cage of that last stage. Now, before we can connect this in, though, we need to in this bit of housing. And so you'll find this plastic bag with some of the here, little components. You want to hang on to all of these nuts and screws because they will come in handy for connecting the gearbox to a bigger robot, which we'll be doing that a little later in the class. For this first project, you don't really need them, but maybe we will. So the first thing to do is find this E-ring and these two washers. Now, it's important to put the washers on and put this properly in the housing before you put the E-ring on. If you put the E-ring on first, it can be really, really tough to get that off. It's quite tight in there. So we put one washer on first, then we put the upper shaft into this housing element. And actually, before I really fully set this in there, I'm going to put some grease. This is a very important moving part of our assembly that will have a strong effect on friction losses here. And again, a nice three-bedded diagram of that. The interaction between this output shaft and this part of the housing would show you that you've got this potentially a very large force multiplier because of a radial load out here and the shorter lever arm. Those 2 points, those two contact points of the housing on the shaft. Okay, so we've got a washer inside the housing on the shaft, and we've got a washer outside, and then we place a retaining ring on there. And a nice way to do this is kind of put it in place, and then you should have some pliers. Take the pliers, and looks like mine's already magnetized. Place the pliers there, and then again, kind of clip it into place. Let's try. Third time is the charm. This is a little finicky bit, and like I mentioned, you really don't want to put this on before you're ready, because it's hard to get off. All right, so there you've got the E-ring in that groove, and that retaining ring will keep the shaft from going axially in and out, and that'll keep it from, say, damaging the gears if it's loaded axially. All right, the next thing you're going to need is these footers. And these, since we're using this high gear ratio 4:1, we need the long screws to put it all together, and then we'll need 3 nuts. So once again, we'll try to put this thing together, make sure everything's smooth and beautiful. All right. There we go. That's all lined up, and now we'll add the output also, and that should click in place. Everything should kind of fit nicely without a lot of pressure. And we are going to take a look at this, and it's best to put the footer such that the tab of the motor doesn't stick out to the bottom. So you know, this since the motor clips are on those sides, this is going to be the side where we put the feet. Place this front footer facing backwards, because otherwise you have it sticking to the front can interfere with your capstan. If that makes sense. So keep that facing backwards. And then we'll put our long screws in. You can see why it's good to protect the leads on that motor. They get bumped a lot. And they can, unprotected, they get bent really easily. Alrighty. It's all looking pretty good. Then we'll, why don't we put the nut on for this top screw. Just kind of put that on by hand. Just hand tighten that one to start. And then we'll put the footer on the back, and you can put it either way, but actually having it face inward makes it a little easier to tighten these nuts. So let's have that footer also facing inward. Hi. Okey-doke. All right, and then just check that everything is working okay. Try to, oh, yeah, we're at 401. This is going to be hard to turn by hand. When we tighten it just a little bit more than that, you can get yourself a screwdriver and your pliers, and then, or if you have a nice, the right size crescent wrench or something like that, you can use that. And tighten that. Doesn't need to be too super tight. In fact, you might not want to tighten it too much at first. Make sure that things working okay. Let's see. Yeah, I can come in from the top here. That is why it's nice to do it facing inwards. All right, that looks pretty good. Okay, so this is what if you assembled it with 400 to 1, your gearbox should look something like this. Now, in order to connect it to a capstan, you're going to want to connect the spring pin. So, and we recommend using the spring pin and not putting the spring pin through anything. You also get this, there's the shaft coupler. You might end up using this in a later project, but it is really tough to get this shaft coupler off if you put the spring pin in first. So if you're not sure, probably best not to put that in yet. Certainly for this project, you don't want it. So you kind of get that a little bit started, and then you can sort of shove it in with the pliers. And what you're going for is about 50-50 on both sides. Now you might be tempted, let's see if we get that just right. You might be tempted to grab this thing and start trying to pull, but it's a bit sharp, and especially if you've got a large gear ratio. Here I've got a randomly chosen, I have a bunch of, which one should I? Let's do this one just because it's easier to hold on to and see. So this is a randomly chosen capstan here, and you gotta really push it in there, and then, ooh, you can hear that. I'll hold it up to the mic. Yeah, that's a big gear ratio. And et voila, this is what everything should look like when it's all assembled. And note that this is not an endorsement. All right, the other thing to do here would be take my power supply, turn it on, and set it to, set it to the nominal voltage of 4.5 volts, manufacturer specifications, and I think this should just barely reach it. And then we'll connect one lead over here. And then what I'm going to do is to turn the motor on and off. I won't turn the power supply on and off because it sometimes doesn't turn off right away. So instead, I'm going to connect it like this. Ooh, the lovely sound of this ultra high efficiency wink wink gearbox moving. And then to turn off, I just release the clip, the alligator clip. All right. That is how you assemble and use your Tamiya 72001 planetary gearbox set. Enjoy.